Good day. Today we're going to be talking about the depreciation, specifically the sinking fund method. Let's discuss depreciation and the sinking fund, those two keywords before we start. So depreciation is basically the decrease in value of a product due to age or time. There are four methods: the straight line, the sinking fund, the sum years digit, and the declining balance. The second of which we are going to be discussing today. So these are the depreciation formulas. So first cost minus book value R equals the total depreciation at time R. So as price goes down, the depreciation goes up. So that's what we're going to do. And at the end of life or N, book value becomes salvage value since you're going to sell it to as scrap. For the straight line method, the formula for depreciation, annual depreciation that is the total depreciation at time R over that time R. Or if it's at the end of life, it's just M instead of R. If using the straight line method, D is constant and there is no interest. So every year there is a small d, annual depreciation added over to the total depreciation, and that annual depreciation is subtracted from the book value at that time. Now, for the sinking fund part of the sinking fund method, it is essentially the amount invested in an annuity to build up interest. So, in an annuity, you pay periodic amounts and constant amounts. So, maybe you pay $100 or 100 pesos each month. That would build up interest. So, for ordinary annuity, this is the formula: F equals A times some factor. And if we isolate A, we get this formula: A equals F times the reciprocal of this factor. These factors have special names: the uniform series compound amount factor and the uniform series sinking fund factor. They're basically just uh, reciprocals of each other, but they do have special names. So, combining both concepts together, the sinking fund method essentially is replacing F and A from our annuity formula with dr and small d. Dr being the total amount of depreciation in time R, and small d being annual depreciation. Now, this is our time since initial purchase. If you want to refer to salvage value or the end of life, you have to replace R with the N. Now, knowing that, let us go with an example question. The Bagger 288 is a massive coal excavator that was bought by the JC Corporation at a price of $14.3 billion dollars. The Bagger 288 is a very big machine that excavates coal. So that's the context for that. It is now 2032 and coal is being phased out by the Philippine government. JC Corporation announces that they would sell the large machine as scrap. 20 years ago, during the year 2012, it was estimated that the excavator lost 30% of its value due to age. This depreciation follows the sinking fund trend with a 4% annual interest rate. What is the annual depreciation value of the Bagger 288, and how much value could JC Corporation potentially recover from the Bagger 288 at the end of its life? Now, before we start computing, let us put the givens on screen first. The first cost is $14.3 billion dollars. We identify that as it was bought in the 1972 at the price of $14.3 billion dollars. Pesos, sorry. And its depreciation at year 40. It was mentioned here that it lost 30% of its value during the year 2012, which is 30 years, no, sorry, 40 years from the year 1972. So that should be D40. And the book value at 40, in case we need this, is 14.3 billion minus 4.29 billion, which is nicely 10.01 billion pesos. Our interest rate is 4% per year, so we don't need to put the period, so just I. And N is 60 years, which this is the end of life. What are we required to find? The annual depreciation and the end of life salvage value. For the annual depreciation, we need small d. And this is the formula. Small d, annual depreciation, equals big DR, which is the total depreciation at time R, times the uniform series sinking fund factor, which is that. Now let's just put everything as that is required here. So 4.29 billion is dr times 0.04 over 1 plus 0.04 to the power 40, which is the amount of time from the start to 2012 minus 1. Our annual depreciation turns out to be 45,145,769.20. You can store that in your calculator. Now, for the salvage value, we need to remember our annual depreciation from earlier, 45 something million. And this formula, uh, which is the formula for total depreciation, being total depreciation equals annual depreciation times the uniform series compound amount factor. So before we do that, we need the salvage value, and nowhere in the second line is the salvage value. But we know that the total depreciation is first cost minus salvage value. And isolating salvage value, we get salvage value equals first cost minus depreciation times the uniform series compound amount factor. Now, we have first cost, we have depreciation, we have interest rate, we have end of life. I think we can compute for salvage value. So salvage value is this. Using your calculator, we get 3,555,727,454. So, in conclusion, our annual depreciation is 45,145,769.20, and our salvage value at the end of its life is 3,555,727,454. Thanks for watching.